All right, in this section, we are comparing two means. So this is topic 22. Our objectives are to look at the techniques for a two-sample t-test. So, of course, when we have a quantitative variable, we do a t-test, not a z-test. And then we'll also do confidence intervals. They're t-intervals for comparing two means. So the last topic 21, we were comparing two proportions. So, of course, the basic ideas behind all the methods are going to be the same, but slightly different because we're dealing with quantitative variables. Before we go into the examples, let's just pull up what the test is actually going to be. So supposing that we have two means that we're looking to compare, our null hypothesis is really going to be, are the two means the same? And then our alternative hypothesis will be either, well, maybe the first one's less than the second, or that the second one or the first one's more than the second, or just you're not sure which way it might go. Maybe you're just testing to see if they're different. Another way, so this is kind of an intuitive approach to comparing the two means, but actually what the test that we're going to be doing, our hypothesis will be that not just that mu1 equals mu2, but if you just subtract both sides, mu2 from both sides, our null hypothesis will be that mu1 minus mu2 is 0. And then the alternative hypotheses, the way that we will word them and the way that we're going to put them into our guru is by subtracting mu2 from both sides, right? Mu1 minus mu2 is less than 0, negative, or greater than 0, or just not equal to 0. Okay, we're going to compute the test statistic. In these videos, we'll do that by hand once, but then in general, you just let our guru do the observed t statistic. And that will be the difference between the two sample means over the square root of the first standard deviation squared over its sample size plus the second standard deviation squared over its sample size. So that will be our t-stat. And then our p-value or our probability, we're either going to be calculating the probability that the t-value is less than or equal to that t-stat, or greater than or equal to, or just not equal to. So that's the two-sided t-statistic. So we'll do twice the probability that it's greater than whatever that value is. Okay, and that capital T df, that represents the t distribution with degrees of freedom equal to the smaller of either n1 or n2 minus 1. Okay, so all of that kind of is dealt with in the background when we're using technology to compute these tests. Also, the confidence interval. So we're going to find a confidence interval for mu1 minus mu2. We'll find a critical value, T star, with a corresponding degrees of freedom. And again, we could do that by hand by looking at the table in the back of the book for a corresponding critical value that corresponds to the confidence level that we're interested in. But really, we'll just let our guru do that in the background. And the technical conditions that you need to be aware of course, first and foremost, this is only valid if our data arise from a random sample or a random assignment of subjects into two treatment groups, right? So we always need randomness. The other technical condition is that either both samples are large, like the sample size for both sets of data is bigger than or equal to 30, or that both populations are approximately normally distributed. So if your sample size is small, you might want to do a normal probability plot to take a look and see, well, does my data look approximately normal? Okay, so these are the things that we're going to be learning how to use in the next activities.